Welcome to another exciting video brought to you by Upvision Concepts Academy. In today's video, we'll be looking at differentiation applications, and we'll see how we apply differentiation. We'll start by analyzing equation of a straight line. So the basic equation of a straight line is y is equals to mx plus c. Y is equals to mx plus c, where y is the variable on the y-axis and x is the variable of the x-axis. M is the gradient or slope. So if we have the differential plane like this is the y-axis and this is the x-axis. Of course, you have the positive y and the negative y, then the positive x and the negative x. So if a line passes through this plane, if it passes through this plane, there is a change in y this way, that is from this point to any point here, and the corresponding change in x this way. You understand? So we have the gradient as m. So m is the gradient, c is the intercept on the y-axis. Okay, so I say m is equals to the gradient and c is the intercept on the real y-axis. C is the intercept on the y-axis. Okay, so if you are given points in this line, for example, to find the equation of a line, to find the equation of a straight line passing through P, then we're given the points 3 and 2, and point Q, and we're given the points -2 and 1. So if you see anytime you are given Cartesian, points like this is point P. The first value they give you inside the bracket is the x coordinates, and the second one is the y. So it's in order x and y. So at this point, P is located at coordinates 3 on the x-axis and 2 on the y-axis. For this one, Q is located at point coordinate -2 on the x-axis and 1 on the y-axis. So if you want to get the line passing through these 2 points, let me get this up so that I can. Okay, let me first of all. So these are the 2 points. So we are going to write 2 equations for these 2 points. Now, we know that the formula for the line is straight line is y is equals to mx plus c. We have defined all these parameters, and then for P, for this point, this equation now becomes, when we have y, we put 3, so it's 3 is equals to mx is what? 2.2 plus c. So for this particular point, this is the equation, and for this particular point, Q open bracket -2 and 1, the equation becomes, so have -2 is equals to m dot 1. 1 is, sorry, I got this mixed up. This is x should be here. X should be here, and Y should be here. So it is XY, XY. You understand? So for this one too, it is 1 for Y and X for -2 plus C. So these are two equations. So I'm going to solve it simultaneously to get the what M is and what C is, so that we can plug it back into this equation and get one equation that represents those 2 points. So I will just remove this one up. So I will express on, well, this is 3m plus c is equals to 2, equation 1, of course. Then minus 2m plus c is equals to 1, equation 2. So I have two equations. So I'm going to solve simultaneously. So I can now say from 2, make C subjects. So C standalone, 1, this one will become plus 2m. Let me call this equation 3. We'll name it equation 3. So we'll put equation 3 into 1. So substitute 3 into 1. So I'll write 1 again, 3m plus, where I see C, I put definition of C. This is how C is defined in 3. So 3 has entered into 1. Then I have 2 there. Then at this point, this is 3 plus 2 is 5m is equals to 2. This one goes the other way, 1. So 5m is equals to 1. 5m is not 5 million, it's just 5 letter m. M is equals to 1 over 5. So this is the gradient. M is 1 over 5. Now I can put this in C again, put in 3 to get C. So where I see C, C is equals to 1 plus 2m. M is 1 over 5. So C is equals to 1 plus 2 over 5, and C is equals to 7 over 5. So I've gotten C and M. I can now come back to the equation of line to plug in those values. So let me just take this one off. So I will make reference to this equation of the line. So the equation of the line is y is equals to m is gotten as this 1 over 5, then x plus c is 7 over 5. So this is the equation that satisfies those two coordinates. These two coordinates. This is the equation that satisfies these two coordinates. So you can still express this one further by saying multiply each term by 5. So when I do that, I have 5y is equals to x plus 7. So that equation satisfies those two coordinates. So you are given two, in this situation, we're given two coordinate points to find the equation of that line. What did we do? We took each of the points and plugged into the equation of a line, a straight line, and get an equation for it. Took the second point, plug the variables x and y into the formula for line equation of a straight line to get an equation 2. So we have two equations where the gradient is unknown, and the intercepts is unknown as well. So we can solve simultaneously. Get m and get c. Use those two variables you have gotten, m and c. Go back to the equation of a line and plug it there. So this is for a situation where we have two coordinates to find the line of the equation of the straight line. What if we are given just one coordinate, 1 point, and we are told to find the equation of the line? There's a formula for it. The formula is gradient m is equals to change in y over change in x. Now, I have this y written separately, differently. This is the y in the equation of the straight line, and this is the y that is present in the coordinates that is being given. So you have two coordinates. So if you are given coordinate x1 and y1, that's what we have here. So this one is the x and y that will be in the equation of the line. So you are given this and you are told to find the equation of the line. You are given one coordinate and the gradient. You are given one coordinate and you are asked to find the equation of that line. Okay, so we will do a simple example to illustrate this. So if, for instance, we're saying that we should find equation of the line. Equation, let me put find on top so that it can be complete. Find the equation of the line through the point. Okay, we have a point here, -2 and -1, and having gradients minus, is it minus now? Having gradient half. Yes, having gradient half. So we have to find the equation of the line. So you see this situation, I'll just give you 1 point and the gradient. So this is the formula we're going to use. Okay, so let me just say m is given as half. x1 is given as -2. And y1 is given as -1. So you have all this. Just put it in this equation. You get your equation of the line. You get your gradients. Okay. All right. Sorry, I said gradient. Equation of the line. So m is half. Already. That's half here. Then y is not given. That's what we're looking for. We're looking for it in the equation. So this is -1. That is, this minus is this one. Then this entity is -1 all over. I have x minus, then x1 is -2. So from here, it is half is equals to y plus 1 and x plus 2. So at this point, I can multiply each term or cross multiply. So let's make it like this. So this will multiply this. I have x plus 2. This will multiply this. I have 2 into y plus 1. So the equation is forming gradually. So open the bracket, 2y plus 2. So at this point, I can decide to put y on this side and put x on the other side. So, okay, let y remain here. And x is here. Then 2 minus 2 is 0. So 2 minus 2 is 0. This 2, which come here is -2 is 0. So I have it as x is equals to 2y, or you can express it as x over y is equals to 2. Anyhow you want, but this is the final equation of the line. In the same vein, if we are given another two coordinates, we are given another two a coordinate and the gradient to find the equation of the line. A coordinate. If we are given, okay, say the line. Let's say the line passing through 2 and -3, okay, and having gradients -2 is, so this one too, the line passing through, you know they are asking you to find the equation of the line. So m is equals to y minus y1 over x minus x1. So the gradient is changing y and changing. This is not differentiation. Changing y and changing x. Okay, so the gradient here is -2. I'm looking for this guy. This guy is -3. I plug it in here over x minus this guy is this one 2. Okay, so -2 is equals to y plus 3 all over x minus 2. Again, this one go up, continue here, and goes up. So I have it as -2 open bracket x minus 2, okay, is equals to y plus 3. So at this point, I will open my bracket, -2x plus 4, because this time this is -2x, -2 times -2 is +4, is equals to y plus 3. So at this point, I have it as 3 goes to join this one, -2x is equals to +1 is equals to y. So this is the equation on that line. Or I can say y is equals to 1 minus 2x. Any one, how you want to put it. Okay, so that's the so it is worth remembering the formula for equation of a straight line given a set of coordinates and the gradients. Just remember that the formula is y, I can do like this, y minus y1 is equals to mx minus x1. So remember that formula. Okay. All right. So we are also going to briefly look at how to test for perpendicularity. Perpendicularity. From the word perpendicular means that two lines are at right angle to each other. So condition for perpendicularity. I'll put it here like this. Condition for perpendicularity. All right, so I'm going to pronounce the words as it's being spelled. If two lines are this one line, this another line, they meet at right angle. So this is line 1, L1, and L2. The lines are perpendicular. So for this to happen, understand, the product of their gradients, if this one, for instance, is m, gradient of this one is m, and this other one is m1. So the product of their gradients, which gradient of those two perpendicular lines is equal to -1. I'll put it in mathematical form. So if I have two lines, L1 and L2, where L1 gradient is m and L2 gradient is m1, m dot m1 is equal to -1. This is the condition for perpendicularity. If the two lines are perpendicular, the product of their gradient will be equals to -1. Okay. So we are going to consider two straight lines. We consider two straight lines. Let's consider these two straight lines. Consider the two straight lines. Two straight lines. Okay, so the first straight line I'm looking at is this equation. 2y is equals to 4x minus 5 and 6y is equals to 2 minus 3x. So these are two straight lines. Okay. So if we convert each of these to the form, that is these two of them, as y is equals to mx plus c. If we do that, so we can identify the gradients for each one. For each one. If you do that one, I can write this one in the form of this. We can do that quickly. It's not difficult. So I want to write this one in the form of this. So I will just say y is equals to, divide each term by 2. So I have 4 over 2x minus 5 over 2. So this one is equals to 2x minus 5 over 2. So at least I can identify that for this particular equation, the gradient is 2 because the gradient is coefficient of x, where there's no coefficient in y. When y is main subject, the gradient is the coefficient of x, and the constant term is this one. The intercept, sorry, is that one, 5. So, and even this one too can be expressed in terms of this form. Look at it. 6y over 6 is equals to 2 over 6 minus 3x over 6. So I cancel this one. Y is equals to 1 over 3 minus 1 over 2x. So the gradient for this one is minus 1 over 2. Okay. Now, so something interesting is happening here. The gradient of this line is 2, is it not? And this one is minus. Okay, so let's call this line m. Let's call this line m. M is equals to what? 2. And let's call this one m1. M1 is equals to what? Minus half. The product of these two, if they give me minus 1, that means these two lines are perpendicular. That's what I'm going to say it is. And that is what it's looking like. So if I have m, that I want to put it here now, these two, put it here. So this one is 2, right? So I put m there as 2, right? Then m1 is minus, is what? Minus 1 over 2. When this one cancels out, what happens? Let me write that very well. So this m here is 2, and this one is minus 1 over 2. So I said, when this cancels out, 2 cancels this, what I have left is minus 1. So this condition is satisfied. So it means that these two lines are perpendicular. The only way you can know is when you go through this process to test it. First of all, ensure that y is mean series of formula, and the coefficient of x becomes the gradient given this formula. The gradient is the coefficient of x when y is made the series of formula, and for this case, the same thing. The coefficient of x here is made series of formula when the coefficient of x here is the gradient when y is made series of formula. Okay, so we can see how we can quickly test for it. So we're going to be given some equations to see whether they are perpendicular or not. Already have shown you how these two lines are perpendicular. And perpendicularity does not mean that it must be on this kind of, it's supposed to, right? It can be slanted. This line can be going this way, another line can be going this way. You understand? So this one has a gradient. This one too has a gradient. You see? So one of them is having a negative slope, while the other one having a positive slope. So this is perpendicularity. I'm using this one to locate because I want to show you that the lines are a right angle triangle. But you know, this kind of line, there's no gradient on this kind of line. This is how it looks like. This is how it looks like. That is, one line is just running like this. Another line is now running maybe like this. You understand? So that this one, the gradient is like this, changing y over change in x. And this one, the gradient is like this, change in y over change in x. So that's how it is. Okay, so you can be given some equations to test whether they are perpendicular. If it doesn't meet, if you solve the gradient, if you solve for the gradient of each of the equations and their product does not give you this, you know that those two lines are not perpendicular. So it's easy. I don't want to go through the process of testing perpendicularity of lines. Okay, all right. So If at this point you're not subscribed, you can subscribe to our channel to get more educational content. And at this point, we'll stop for today. I hope this video has been informative for you. I'd like to thank you for viewing.